Traveling Salesman Problem. What's the complexity class of the best linear programming cutting plane techniques? I couldn't find it anywhere. Man, the Garfield guy doesn't have these problems. Title text, what's the complexity class of the best linear programming cutting plane techniques? I couldn't find it anywhere. Man, the Garfield guy doesn't have these problems. Planation next. Explanation. The traveling salesman problem is a classic problem in computer science. An intuitive way of stating this problem is that given a list of cities and the distances between pairs of them, the task is to find the shortest possible route that visits each city exactly once and then returns to the origin city. A naive solution solves the problem in on time, where n is the size of the list, simply by checking all possible routes and selecting the shortest one. However, this approach will take a long time as the number of possible routes increases super exponentially as more nodes are included. A more efficient dynamic programming approach, the held-carp algorithm, yields a solution in on22n time. These times are given using big O notation, which is commonly used in computer science to show the efficiency or complexity of a solution or algorithm. The joke is that the salesman selling online, say on eBay, Amazon Marketplace, or other virtual marketplace, does not have to worry about this problem, since he does not need to travel, which makes the time to find the best solution O1, to which the traveling salesman angrily responds, "Shut the hell up." The title text wonders about the time complexity of the cutting plane method, which is sometimes used to solve optimization problems. The last sentence suggests the downside for Randall of drawing comics about computer science. He sometimes encounters problems to which he cannot find the answer, whereas authors of simpler comics such as Garfield do not have this problem. This is also likely a reference to 78, Garfield, which parodies Garfield's simplicity. The map almost certainly depicts the United States, with the locations highlighted suspected to be from left to right: Seattle, San Francisco, Los Angeles, Phoenix, Denver, Minneapolis, Dallas, San Antonio, Houston, Chicago cut off, Detroit, Atlanta, Miami, Washington, D.C., Philadelphia, New York, and Boston. This is so far the only comic featuring the brown hat character. Also see earlier strip 287, NP complete. Transcript. There is a linked black web, with a path in red. It appears to be a map of the United States. Brute force solution, ON. The web continues in this one. A man with a brown hat and a case is drawing it. Dynamic programming algorithms, ON22N. Another man, with a brown hat too, is at a computer, looking back over the chair. Selling on eBay, O1. eBay salesman, still working on your route drawing salesman, shut the hell up. Discussion. Does anyone remember if the brown hat appears in any other comics? I'm not sure, so I created a category and page for him. Let's see if that catches any others. Jeff Talk 2204, March 29, 2013 UTC. According to the transcript, we have two different brown hat guys here. I'm working on this -DGBRT Talk 2149, October 5, 2013 UTC. I'm inclined to think that brown hat is specific to this comic, the brown hat being the 50s style Homburg or fedora common to salesmen trying to look respectable. Randall likely added the hats to depict folks from a bygone era, one of whom has caught up with the trend. Irony. Chef Talk 149, January 10, 2014 UTC. The second brown hat guy seems similar to Black Hat both in personality and hat shape. Could he be the same character? Richmond Tudor Talk 322, March 13, 2015 UTC. It's probably not in the least important, but the network appears to be a collection of key cities in the US arranged by geographical location. 130.160.145.185 March 9, 2013 UTC. Added a better explanation of the title text. Nick 5 October 2013 69.193.7.67 Talk. Please sign your comments with. Has anyone answered the question in the title text? Rickety Bridge Talk 2355, January 9, 2014 UTC. It is bitter news that in the 40 years since held and carp no better guarantee than N2.2N has been found for the problem 1. So whereas linear programming techniques tend to be quicker than other algorithms, they have not been shown to be better than ON2.2N.141.101.98.55 August 17, 2014 UTC. Doesn't someone at eBay still have to solve the TSP? I guess that's the entire point though. 141.101.85.223.848, July 27, 2014 UTC. No, because you can send your sales information to all customers at once because they come to you, electronically. It takes no longer for you to be viewed by 100 people than by one person. Thus 141.101.98.55 August 17, 2014 UTC. I never used eBay, so I don't know how it works, and I'm probably missing something obvious. Maybe it should be explained at the explanation. If you wanted to personally sell about 17 items to 17 cities like the guy on the left, you have to visit each city by car or something. How does eBay visit the 17 cities to send the items? 141.101.85.199634, August 19, 2014 UTC. You don't have to personally visit each buyer. You put a description of the item you are selling online on eBay, and then people can decide to buy or not. If they do buy, they pay you online. Any communication is done online, and you send them the item in the mail. I don't think it's necessary to have an explanation of how eBay works, as the majority of people would know. Putter Talk 1631, December 8, 2014 UTC. Oh God, wish I could vote this up, somehow. 108.162.219.108 June 11, 2015 UTC. It is curious that nobody here appears to have noticed that ON is equivalent to ON log n. Last time I checked, I seem to recall finding that ON log n was under ON2, and therefore under ON2.2n. Or have I missed something? Certainly the worst case can't be over ON log n, as this is the class of the number of ways to sort a list of the cities. So, then, the ON2.2n must be better by some other multiplier. Come to that, ON2.2n seems to be within O2n. What am I missing here? 108.162.250.1342227, August 9, 2015 UTC. I find it more curious that you think ON is equivalent to ON log n. It most certainly isn't. ON log n is provably the optimal complexity of a comparison sort. ON is the complexity of BOGO sort, one of the stupidest sorting algorithms imaginable. 162.158.90.162.2123, August 23, 2015 UTC. This is so, but when one examines the theory of big O notation, one finds that they are mathematically equivalent. The point, therefore, is that the difference is purely in form. To illustrate, a list has ON permutations possible. A sorting algorithm can therefore never sort a worst-case random list with less than ON Comparisons, as this is the minimum required to get the list in the correct order for the best case, when we assume the worst possible list for the algorithm. It is possible to prove that On is On log n re-expressed. Therefore the difference seems merely to exist to highlight the general behavior to humans. Agreed, however, that until the advent of the wave function-based quantum computer, the BOGO sort is as bad as it gets. This does not change the fact that any comparison sort must distinguish between On lists, and therefore can never do that with less than On minus 1 equals On comparisons. The proof of the n log n barrier rests on this, and n log n is merely a nicer looking way of writing n. Here. Unless I have encountered a flawed proof, this should hold, and even then, the number of possibilities that must be distinguished should bound it. Provided of course that this idea, too, is not logically flawed. If so, how, and if not, then why the notation is this somehow applying the same logic that distinguishes a binary sort from a linear one to the set of possible orderings? If so, it must be functionally pre-sorted, by some logic. Where have I erred, if I have erred, and, should I have erred, how might the correct solution be explained? 108.162.249.1831121, September 2, 2015 UTC. It is possible to prove that On is On log n re-expressed. Then prove it. Any comparison sort must distinguish between On lists, and therefore can never do that with less than On minus 1 equals On comparisons. This suggests to me that you've never written a comparison sort. Here's merge sort in JS. Window.comparisons equals 0, function merge underscore sort ARR. If ARR length equals 1, return ARR. Var left equals merge underscore sort ARR slice 0, math.floor ARR length 2, var right equals merge underscore sort ARR slice math.floor ARR length 2, var LP equals 0, var RP equals 0, for var AP equals 0, APARR length, AP++. Window.comparisons++, if RP equals right.length LP left.length and left LP right RP. ARR AP equals left LP, LP++. Else. ARR AP equals right RP, RP++, return ARR. Console.log merge underscore sort 5, 4, 3, 2, 1, comparisons, 12, log 25 is 2.3, seal 2.35 equals 12, 5 is 120. Window.comparisons equals 0, var ARR equals, for var I equals 0, I 116, I ARR I equals 116, I. Console.log ARR, 1 through 65,536. Console.log merge underscore sort ARR, comparisons, 1,048,576, log 265,536 is 16, seal 1665,536 equals 1,048,576, 65,536 is 510,287,193. If what you said was true, modern computer science would collapse. Even if you don't believe me, you have to concede that the mere fact you can sort 65,536 things before the heat death of the universe is proof that you did the math wrong. 173.245.54.28342, November 19, 2015 UTC. 1. I think you might be confused on how math works. N refers to factorial 1 2 3, n. n log n is n multiplied by the logarithm of n2. Didn't read all of the rambling, but it seems like you believe a list can only be sorted by brute force, going over each item and comparing it to the rest of the list. This would in fact be n. Most sorting algorithms do not use the brute force method since humans are built to recognize patterns and come up with algorithms regarding those patterns. Fluke Talk 113, December 28, 2015 UTC. Actually, it's not ON. That is equivalent to ON log n, but O log n is. See Stirling formula for details. Seems your memory just dropped that log. 198.41.242.245.857, June 27, 2016 UTC. Thank you to all of ya helpful contributors. I am not sure what led me to write the seed of this tiredness, but it is, as noted, a complete and steaming pile of rubbish. Duty calls, and so forth. I hope I have inadvertently amused someone. Possibly this is a result of abstract mathematics being learned at around 4 layers of abstraction. Have a good day night. 162.158.58.141.935, December 26, 2016 UTC. Running time of dynamic programming has changed. BTW The running time the dynamic programming solution, ON22N should be changed now, https ar14.org abs 2405.03018 Mihail.Stoyan Talk 1921, May 8, 2024. Please sign your comments with